Okay, we're back. The next section we're going to look at are parallelograms. Now you guys may have seen these parallelograms before, and that's a great thing. So we'll just kind of refresh, and if it's new to you, that's great as well. There's a lot of things to learn about these. So a parallelogram is a quadrilateral, remember that's a four-sided figure, with both pairs of opposite sides parallel. And we should see these markings right here and understand that those mean they are parallel. Okay, so we've got opposite sides that are parallel. The symbol that you're going to see is this one over here on the right-hand side. That symbol there represents a parallelogram, and that's the biggest thing to remember, is that means that opposite sides are parallel. Okay, that is a parallelogram. Now what this does, it gives us a bunch of theorems having to do with parallelograms. So here's a few of them. If a quadrilateral is a parallelogram, then opposite sides are congruent. So I've got a parallelogram here in this picture. I've got opposite sides congruent here and here. I've got opposite sides congruent here and here. Alright, so if it's a parallelogram, that is the case. They will always be opposites. They will always be congruent, rather. The second thing is, if a quadrilateral is a parallelogram, its opposite angles are congruent. So you see here angle A and angle C. Those are opposite each other. Those are congruent. Again, angle B, angle D, those are congruent. Okay, so opposite sides, opposite angles are congruent. That's really important to remember. Now, a few more. If a quadrilateral is a parallelogram, the consecutive interior angles are supplementary. Now, what that means is consecutive interior means they're right next to each other. So, in this case, you have X and Y. Those are consecutive interior. Okay, you have X and Y going this way. They are, again, consecutive interior, and we talked about those when we dealt with parallel lines. Those are supplementary, meaning they add up to 180 degrees. Okay, so you will be shown that again in the future. Alright, the next one. If a parallelogram has one right angle, then it has four right angles. And the reason is the ones that are opposite have to be congruent. So if this were a right angle, and the picture does not do this justice, but if this were a right angle, that one would have to be a right angle. And since these two are consecutive interior, they add up to 180, and the only way that's possible is if that's 90, meaning this one would also have to be 90, and there's that. Now again, that picture does not show that the correct way, but that's what it's saying, based on the theorems we've already seen. Alright, next one. If a quadrilateral is a parallelogram, its diagonals bisect each other. So if you've got a parallelogram, looks something like this, and then you've got diagonals. Now remember, diagonals connect opposite vertices. Well, what that says is they bisect each other. So that means that this is congruent that way, and this is congruent that way. And that helps us because if we're given a problem that has diagonals, we can set those equal to each other. Alright, next one. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. And what you can think is, based on this picture that I have up here, this blue triangle and this blue triangle are congruent because you have side-side-side relationship. And we talked about that before, and side-side-side is enough to prove triangles are congruent. Okay? Alright, so here we go. We're going to solve some of these given some information and those proofs that those theorems we were given above. Alright, so QRST is a parallelogram. Because that's true, solve for the variables. So I've got three variables here. I've got an X, I've got a Y, and I've got a Z. And we need to figure out what the X and the Y and the Z equal. Okay, a couple of different places you can start. Now let's just go with the X. Okay? The X has the side QR, it's 5X. Now, because this is a parallelogram, opposite sides are congruent. So what that means is that your 5X is equal to 27. They are congruent. So solving for X, you divide by 5, that gives you a value of 27/5 for X. Okay, now moving on. Let's look at the Y's. Well, the Y's are along the diagonal. Well, one of our theorems said that if you have diagonals that are in a parallelogram, they bisect them, which means that these two things would be congruent. And we can solve that by just setting them equal. So you've got 2y minus 5 equals y plus 4. Anytime two things are congruent, they are equal, and you can set them equal. So I solve this out, so subtract y, I add 5, those cancel, and I end up with y equals 9. And there is your answer there. Now finally we need to figure out what z is. Well, z is an angle here. Well, if you think about what you have, this line is parallel to this line. You have this line cutting it down the middle. And a few sections back we talked about transversals, and that's a transversal. So they are alternate interior with that angle right there. So what that means is they're congruent. So 3z equals 33 degrees. You divide by 3, that gives you z of 11. And there are your three answers. X is 27/5, y is 9, z is 11. Alright, take a minute, try that second example, pause the video if you would, and come back when you're done. Okay, hopefully you guys had a chance to solve these out. Let's look and see how you did. So for this first one, we're going to solve for r. Okay, here's 4r and 18. Those are congruent. So 4r equals 18. You divide by 4. That gives you r is 18/4, which we can reduce that down to 9 halves. Alright, the next one. We've got these two here. Again, because they are diagonals bisecting each other, they are congruent. So you've got 8s is equal to 7s plus 3. So subtract 7s. Those cancel. You get s equals 3. There's your second one. And finally, here's 2t. Well, 2t is going to be an alternate interior with 18. So 2t equals 18. Divide by 2. And t equals 9. And there you go. Alright, so that's how you can work through these problems using some of these properties and theorems. Alright, final part of this is we want to be able to write proofs. Okay? So with this proof, they're specifically asking us to do a paragraph proof. Now, any proof, you start with a given. Okay? So in this proof, we're going to say given parallelogram ABDG and AF being congruent to CF, here's what we can decide. Well, opposite angles of parallelograms are congruent, which means that angle A is congruent to angle C. Okay, or sorry, let me go back. Angle D. I apologize. So angle A is congruent to angle D. Alright, now look at what we want to prove. We want to prove that BDG is congruent to angle C. Alright, now what that's basically saying is BDG is this angle right here, congruent to this angle right here. Well, let's continue on and see what we go. We know that AF is congruent to CF. So since AF is congruent to CF, what does that give us? Well, those two sides of that triangle tell us that this is an isosceles triangle. So ACF is an isosceles triangle. Now, based on the definition, so by definition of an isosceles triangle, since AF is congruent to CF, angle A is congruent to angle, sorry, I did that again, angle C. And that's strictly by definition. Well, up here above, now I'm going to highlight this, we said that angle A is congruent to angle D. Right here, we said that angle A is congruent to angle C. Well, what that means is that by transitive, angle C is congruent to angle D. And because of the reflexive property, or you could say substitution, either way, angle D is the same as, is equal to, I don't want to say congruent, or is equal to angle BDG dg, and therefore that proof will hold. Alright, so that's one of the ways that you can work through these. I mean, like any proof, just start working through, make sure you're following any theorem, any definition, any postulate that you can show actually holds those truths, and then try to get to your question that you're trying to prove. Alright, if you have questions, contact me. Otherwise, go ahead and try your assignment, and I'll talk to you soon.